and welcome back. In this lecture we'll see how we can use Matplotlib in conjunction with Scipy's stats library. Okay, I'll show you how we can draw various plots by using some of the functions in Scipy stats. Okay, so as usual we import NumPy and Pandas, and from Matplotlib we import pyplot as PLT, and we'll also import Scipy stats. Okay, so from Scipy stats we'll import the norm function. Okay, so this norm is a library that allows us to plot various kinds of probability density functions. That's what we will see in this lecture. Okay, so let me create a range of numbers. So I'll create an array np.arrange, let's say from -5 to 5, and in step sizes of, let's say, 0.01. Okay, I'm going to plot a probability density function from this. Good. So I'll save this in a variable called x. So that will be my x-axis. Now let's plot that. plt.plot, and then we pass our x-axis, and for our y-axis, since it's going to be a probability density function, there's a method called pdf in norm. Okay, so I'll call my norm that pdf, probability density function, and then I pass my x variable. So this will create a probability density function of x. Okay, so that's how we can use the Scipy's various functions in the norm, and by calling the pdf function we can simply create a probability density function. Now let's show the plot. Let's run it. So here is a simple probability density function. Okay, from -5 to +5. Okay, so that's how we can use the probability density function to plot a graph. And we can also include more than one line in our figure. We'll see that next. Okay, let me copy this part, Command C, Command V, and let's put another plot, plt.plot, and then we'll pass a basic normal distribution function. Okay, we'll have x, and then we'll have norm.pdf. We'll pass our x. Let's pass a mean value of 3. Okay, and a standard deviation of, let's say, 1. And then let's show our graphs. Okay, this is what it looks like. I have two plots in one graph. That's how we can show it. Here, let me reduce the standard deviation to, let's say, 0.4. Let's run it again. Okay, now you can see it, right? Two plots in a single graph. That's how we can do it using the pdf function. Next, let's see how we can adjust our axis. So we can adjust our axis by using the set. There are various set methods. For instance, there is a set x limit, which will set the x limits within the given range. there is a set y limit function, there is set x ticks and y ticks. So we look at those next. Okay, let's say plt.axis. That's a method to adjust our axis, and let's save that in a variable axis. Okay, ax. Good. Now by calling that plt.axis, I can pass those set methods. Let's see that. So axis that, let's say set x limit is one method, so this will set the x-axis within the given range. Let's pass, for instance, -10 to +10. Okay, and let's do the same for, let's set our y-axis. So axis that set y limit, and we'll pass between -2 and 2. Let's say -2 and 2. You can put any value. Okay, before I set the x ticks and y ticks, let me show you what it looks like now. Okay, and let me call my two functions here. So I'll have my two plots. Okay, plt.plot x, and then we have a probability density function of x, and for the second one we have a probability density function of x, a mean value, and standard deviation. Okay, let's show our plots by calling the show method, run it. Okay, this is what it looks like, and we can adjust this x limit and y limit. Let's put -6 to +6, right? And for y limit, since our axis is at 0, there's no need to put -2 to 2. It won't make much sense. So let's put 0 to 2 and run it again. Okay, it looks much better now. And to cap it at the y max, we can change this to 1, so it will cap it at 1. Okay, this is how we can adjust the x limit and y limit values. And here we have, the ticks are automatic, so 0.2, 0.4, these are the default tick marks. We can also change those by passing the set y ticks and x ticks methods. Let's see that. So ax, that our axis, and set the, let's say, x ticks. Let's do the y ticks, since we have a lot of values in the x ticks. Set y ticks, and we pass a list of values that we want. Okay, for instance, we can say 0, 0.1, 0.2. So I just paused the video to save some time. I have labeled the y ticks. Let's run it. See, now it has labels 0.1, 0.2, 0.3, 0.4, and so on. And you can pass the same method to set the x ticks. Okay, good. Next, let's see how we can add a grid to our plot. Okay, I'll copy this whole thing and paste it here. Let's see how we can add grids. We can add grids by simply calling the grid method. Okay, So let's add that. So access that grid and run it. Now we have grids in our graph. Okay, we do that by calling the grid method. And we can also change the color of our lines simply bypassing a color parameter. Okay, let's do that. I'll copy that and paste it here. So here in my plot I can pass a color, let's say black, and then for this one let's pass red and run it. So we have one of the lines is black and the other one is red, and we can pass different styles. For instance, if we put a colon, that will make, okay, let's simply put R. Okay, if we pass a colon, it will make the lines a hash, so it will make a hash line. And if we want like a line style, we can pass 2 dashes, for instance B dash dash, run it, and we have a line style. Okay, that's how we can adjust or change the different color types. Okay, the line types. And we can also label our axis by passing the Y label and X label methods. Okay, let's do that. So let's call the X label and Y label methods, which are in PLT. That X label, and then let's say this is X axis, and we can label our Y axis by calling the Y label method. Okay, this is the Y axis. Let's run it. So I have the X axis and the Y axis. We can also add a legend. Okay, we can also add a legend. For that we'll use the legend method. So plt.legend, and then we pass our legends as a list and the location that we want. Let's say legend 1 and legend 2. Okay, let me run it first without specifying any location and show you what it looks like. Okay, so in this case this is the default legend location. Okay, and we can change that by passing a location argument, loc, and that takes values 1, 2, 3, and 4. Okay, let's say legend 2. Legend 2 is there. If we put legend 3, location 3, it places it there. So for our purpose, for this graph, legend location 2 is the best place for our legend. Next, let's see how we can make a normal distributed function. Okay, we'll see a histogram of a normal distributed function. For that, I'll use the normal method in np_random. Okay, so np.random .normal. Let's make a normal distributed function of average income. Let's set it as, let's say 30,000, and a standard deviation of, let's say 12,000 for 50,000 people. Okay, so basically this is a normal distributed function, okay, with our mean value is 30,000. So once we draw the graph, it will be centered at 30,000, and this is the standard deviation, and we are considering 50,000 data points. So people, in this case, our data points are people, so 50,000. Okay, and then let's save this in a variable called average income, and then we'll plot a histogram of the average income. So plt dot hist, and we'll pass the average income, and let's use 25 bins. Okay, and let's show our histogram. Plt dot show, so this is a normal distribution histogram, and it's centered at 30,000. Okay, for 50,000 data points, and you can change this number of buckets. You can pass different numbers, for instance 100. This is the shape of a normal distributed function, the bell curve shape. Okay, let me change this back to 25. Run it again. And we can also make a bar graph by calling the bar method. Okay, let's make a bar graph. Let's say x is equal to 2, 4, 5, 7, and 14. Okay, and let's say y is equal to, or let me leave y and let me set this to y. I'll use a range function for x. Okay, let me add some more values, 22, and let's say 11. Okay, so to make a bar graph, we just call the bar method, and then let's pass range 0 to 7. Okay, and then we pass our y for y-axis. Okay, and let's show it. Plt.show, and run it. So here we have a simple bar graph. Okay, by calling the bar method and then passing our x and y, we can simply plot a bar graph. Okay, and you can change the color by passing a color argument here. Let's say red. Okay, now it's red. What if we pass that? Okay, it doesn't accept those. Anyways, you can change the color by passing a color argument. Okay, so just to summarize, these are the different ways that we can plot graphs by using the PLT library and also the Scipy stat library. Okay, by importing the norm, we can use the probability density function to draw simple probability density function graphs. Okay, and we saw various ways how we can do that, how we can plot the axis, how we can add a legend, how we can add grids, and so on. Okay, thank you everyone, and I'll see you